The concepts that are discussed in the Unit 1, which is actually on the quadratic equations, are actually applicable in real life situations. Sharing to you right now are two of the possible real life problems that will actually cover the contents or the concepts have that were discussed when we talk about quadratic equations. So these are the two problems, and we are asked to give the solutions. So again, when we talk about solutions, we will be asked about the value of the variable which can make the equation true, or just simply we're looking for the correct roots. Number one is all about the area. The area of a rectangular plot is 30 square meters. If the length is 7 meters more than the width, what are the dimensions of the plot? Okay. So we are asked about the dimensions of the plot. Similar to your elementary procedures, we are asked about the dimensions of the plot. So we are asked about what is the length. Let me write it here. What is the length and what is our width? Because if we talk about dimensions, we're asking about the measurement of the length and the width. Let me move it here. And then what are the given values? We are given with an area equal to 30 square meters. And we are given with the relationship that the length, okay, this relationship, I'm just going to encircle it here. Okay, the length is 7 more than the width. Okay, so the length is 7 more than the width. Let us try to uh, assign a variable for the unknown for the length and the width, so that we could actually just look into the relationships of the two when I talk about area later. So we may use the letters for the width, which is W, and L for length, but let's just use the the relationship using the width here. So width is smaller than the length, so we could use W for our width. Since the length is 7 more than it, so we could say that 7 plus W is a measurement of the length. So in short, if the measurement of the width is let's say 5, so the length is 7 plus 5, 12, which is 7 more than 5. Okay? Or you could actually just use, since the addition is commutative, we can just simply interchange it and have the expression W plus 7. For those of you who don't like to use W, you may use still X for the width, and what will happen to the length is X plus 7. Why do we group it like this? Because we're looking for the relation for the measurements or the dimensions of the length and the width. So whatever will be the value for the W later on, that's automatically the width, and the value of the W plus 7, because 7 more than the width, that would be your length. And by the way, like, we are actually for in the meantime, disregarding the signs so that we could just um, manipulate the values later on. So for the area, let's just use muna 30, and let's have square meters later. Okay. Now that we have these values, let us talk about the area of rectangular plot. We all know that the area of a rectangular plot is the product of the length. Let me just use here. We know that the area is equal to the product of the length and then width. Product, meaning we are going to multiply them. So to get this, to get a representative quadratic, equation or number sentence, just simply substitute all the values here. The area is actually given to us as 30. Again, dropping first the unit is equal to the length, which is W plus 7, times the width, which is W. So when we multiply these two expressions here, you will have 30 is equal to W squared plus 7W. We could just simply use a symmetric property so that we could not change signs. This could be actually be W squared plus 7W is equal to 30. I'm just using the symmetric property. Symmetric property tells us, allows us to interchange both sides of the equation. And then we need to subtract both sides of the equation so that we could have an equation in standard form. So we have here W squared plus 7W minus 30 is equal to 0. This is our representative quadratic equation. Since we are solving for the measurement of the length and the width, we could solve the measurement of the length if we could have the value of the W or the width. So we are looking for the W, the value of the W, which can make this equal to 0. So if we have that, we can actually use here the quadratic formula if you want. But of course, we could still use here the factoring method as to solving the variable, the solution, or the roots of the quadratic equation. So you have W and W. Okay. Negative 30 for AC. 1 times negative 30 is negative 30. Product factors of negative 30 that will result to 7 is 10 times negative 3. 10 times negative 3 is negative 30. 10 minus 3 or 10 plus negative 3 is positive 7. So we are going to use that plus 10 minus 30. And then break it up. W is equal to W plus 10 equal to 0. And W minus 3 is equal to 0. And then we have here W is equal to negative 10. And then W is equal to positive 3. Now, these are the possible values for W. We're not saying that both of them are are acceptable, but let's find out later. When we talked about quadratic equations, we accepted both roots as values for the variable as roots of the quadratic equation. But when we talk about real life situations, there might be restrictions as to which is acceptable and which is not. Take note that W is the measurement of the width, and the measurement should not be negative. Well, take note, if you're going to use here W as negative 10, so your length, negative 10 plus 3, is equal to, let's use L, is equal to negative 3. Right? And the product of the two, as solving for the area, length times width, will still be equal to positive 30 square meters. But in the first place, the measurement of the length and or the width should be positive because it's a measurement, it's distance. So my point here is for W, which is equal to negative 10, this is not a possible solution. So you could just say this is that's not a possible solution. Solution. Okay. Let's make, oh yeah, that's okay. Okay. So that is for the value of W, which is negative 10. In short, we will not accept it. What we will accept is 3. Let's find out if the measurement, since it's positive already, and that is actually width, which is equal to 3, the length for that is W plus 7, which is actually 3 plus 7 equal to 10. This is now the measurement of the length. Both of them are positive, so they are possible values for a distance. And when you're going to multiply them to get the area of the rectangular plot, 10 times 3 is equal to 30, and using the units, square meters. Therefore, the answer to the question, what are the dimensions of the plot? You could just simply say here as a final sentence, the dimension of the plot is dimension. So you're going to use by probably as a keyword for multiplication. So by is 3 meters by 10 meters. Okay. So basically, if we talk about 10 and 3, the longer one is the length based on the situation, and the shorter one is the width. And they should contain the unit because we have a unit here, meters. So this is the answer for number 1. The dimension of the plot is dimension. When you say dimension, it should be a just like 2 by 2, 3 by 3, situation. The dimension of the plot is 3 meters by 10 meters, or the other way around, 10 meters by 3 meters. So this is the answer for number 1. We are solving the area, we are solving the measurement, but we actually use the concept of quadratic equations. Let's have number 2. Number 2 now talks about the product of two integers. So it's still product of two integers is 48. So we're going to use here, ah, if they differ by 2, what is the smallest possible value for the smaller integer? So let us use here the given. So the product is 48. I don't have units here because I'm talking about integers. It's 48. And then we have two numbers, smaller and probably the larger. So the smaller integer, okay, is equal to something. And then we have here the larger integer. Take note of the term integer. Okay, integer. They differ by 2. So probably if we are going to use x for the smaller integer, the larger integer is greater to it by 2 because they differ by 2. Okay, so x and then x plus 2. These are the interpretations for the unknown, x smaller integer and then a larger integer. Take note of what is asked. We are asked about the smallest possible value for the smaller integer. So we're just looking for the value of the smaller integer. No need to solve for the larger integer. But in solving for it, we are representing the larger integer as x plus 2. Let me place here separator. Now, so we are going to solve it. So the product is 48. The product of the smaller integer is 48. A smaller integer and the larger integer, the two integers. So you could say here x times x plus 2 is equal to 48 as their product. And then you have your x squared plus 2x is equal to 48. In standard form of quadratic equation, x squared plus 2x minus 48 equal to 0. This is our quadratic equation in its standard form. Let me increase here the area for solutions. It will be longer. Okay, so we have this. We could actually use here again quadratic formula if you want, but I believe this could be factored out. AC is the product of A, 1, and negative 48. So you have negative 48. Factors of negative 48, which will result to 2. You may say 12 and 4 cannot be. Uh, yes, you have 8 and negative 6. You have 8 and negative 6. 8 times negative 6 is negative 48. But when you add 2, it's actually 2. So you have here x plus 8. And then you have x minus 6 equal to 0. Okay. So using the zero factor property here, equate both factors to 0. So x is equal to negative 8 and x is equal to positive 6. These are all the values for the smaller integer, x, negative 8, and x is equal to 8. The pair for this, if you just would like to solve them, additional concern. So the larger integer is x plus 2. So it's actually negative 8 plus 2. So the larger is negative 6. And then they differ by 2. And when you're going to multiply them, 8, negative 8 and negative 6, it will result to the product, which is 48. For the second possible value, smaller or small for the smaller integer is actually 6. So x plus 2, the larger integer is 6 plus 2, which is actually 8. Again, when you multiply them, 6 times 8, you will get the value of 48. So both of these are correct. But the question right now is, which is the correct answer to the problem? The problem here states that the smallest possible value for the smaller integer. So the smaller integer are the values represented by x, and the smaller to that is actually 8. So the statement here must be the smallest possible value for the smaller integer, that's integer, is negative 8. This is the statement which gives us the answer to our problem. But if the problem will be different, let's say the smallest possible value for the larger integer. So you look at the larger integer, represented by x plus 2, the smaller is negative 6. That's acceptable. If the question right now is the what is the largest possible value for the larger integer, that's actually 8. So it depends now on what is the question to the problem. But since you already solved this using quadratic equations, basically we are still using the processes and solving the roots of quadratic equations. The result now will just be different, dependent on the question you need to answer, just like what happened in number one as well. Okay, so these are just two of the few examples, real life examples, which actually covers quadratic equations. So there are many more. You may search on that. You may also try them as a practice for your assessment for this grading. Thank you very much for watching. And we already, this is our actually the last video for unit number one, quadratic equations. So we are already covering everything for unit number one. The next video will be for unit number two soon. Thank you very much. Have a nice day. Goodbye.